Welcome Tech Brothers here. In this video, we are going to learn about RDD transformations. So we are going to study map, flat map, filter, and distinct. So here we are creating a Spark session, and then we are going to take a look on the definition and then move forward with our demo. Now, RDD transformations are operations that return a new RDD by applying a computation to the existing one. They are lazy, only executed upon action, and are building blocks of Spark data pipelines. So what does a lazy means? So let's say if I have this map, filter, or distinct different transformation, and I execute them, there's nothing going to happen. They will create the plan on the back end, so Spark will create that plan to use them. But when you use the count or collect, and those are the action transformation, then these transformations will run and then give us the data. So now we are going to take a look here for common transformation covered here. Now map applies to the function to the each element in the RDD. Then flat map, it is similar to the map but flattens the results. And then we have filter that selects elements that satisfy a condition. And finally we have distinct that removes duplicate elements. Now we are going to take a look on each of them in our demo right here. So here's my sample data. You can see that we have some lines of data here and that we will be using. Now I'm creating a RDD equal to spark.spark context dot parallelize, and then I say lines. So this part of code is going to help me to create the RDD name RDD, and by using this data. Once our RDD is created, what we can do, we can experiment with our transformation. So here's my first transformation. I'm using it. So it's called flatMap. It split lines into the words. So you see that I have Ahmed loves Spark, Ali and Raza loves. So what we would like to do, we would like to split each line into different words. So entire data will be split in each word, and that's what we are going to do here. So here I'm creating a new RDD called the word underscore RDD, and here is my existing RDD, and I say flat map. Then I say provide lambda lines. So I'm gonna input these lines here to this, and then I say line dot split. So that's going to split the entire this data and give us the new RDD called words RDD, and then we are going to collect that and print it out. So you will see how exactly it will look. So here's the result, and you can see that each line is broken into each word. So you can see that we have Amer, then we have comma loves, and then we have Spark, and then we have other words coming from different lines. So that's what we did with the flatten. So flat map, it flattened the whole thing, and then each of this word is separated by comma, because we have used the split function here to split each line here. Now let's take a look on the map transformation, and that converts word to word comma 1. So let's say if for each of the word I want to add 1 to it, and I can use it. And there are other example I'm going to do further down here to show you how exactly different function can be applied on each of the element. Here I'm saying pair RDD, so new RDD we are going to create, and we are creating this RDD from words RDD. And here is our words RDD. Remember that was just a separate element. So right here, so you can see that each one was a separate, and this was our RDD. What we want to do, we want to add 1 to each of the word, and here we are using a map transformation. So you say map lambda word, and then what you want to do, you want to have a word comma 1. So that's what the format we would like to see. And here I'm printing out the newly created pair underscore RDD RDD by using collect function here. So if I will execute this one, now you're gonna see we have this for each of the element we have added 1 to it and make a pair like this, so we can perform some more functions on this. I will gonna show you or perform some more transformation on it. So here we have converted, and let's say if I want to convert everything to the upper, I could have done that too. So I created a new RDD called pair underscore upper, and we will be using word RDD. So that's the one we just created, the very first one where each element is separated by comma. And now what we are doing, I'm using map, then I'm saying lambda word. So on each of the word, word dot upper, make it upper, and then I'm printing right here. So I'm gonna go ahead and execute, and you will see now each word is in upper cases right there. Okay, so you can use a map to apply different functions or whatever you needed by using map on each of the element. Here on each of the element I have use upper, and there in the first one we were just using say word comma 1, so we added 1 to each of the element. Now let's go ahead and take a look on the filter. Filter keeps only the records that we want to keep, but depending upon the condition. In this case I would like to say, hey, keep only words longer than 4 letters. So here I'm creating a new RDD, filtered RDD, and I'm applying on this RDD that we just created on top, words RDD, and then say filter, and then I say lambda word. So take this as an input, and then check the length. So length of word should be greater than 4. So that's what we are doing. So we are filtering here. Now what's going to happen, then we are printing it out. So all the elements which have length greater than 4, they will be shown up here. So you can see that this has 5 characters, this has 5 characters. So this is how you will filter the RDD, by using filter and then providing the condition or whatever the condition you want. Now if you have here, let's say you have a name Amir, right, and or anything you want to just filter for Amir as well. So it doesn't have to be length always. You can say like anything that you want to apply. So now if I will say equal to this Amir, so now if we do so, what's going to happen, if I will run this, now it's going to show me all the elements which has there was actually just example I haven't shown you, there is only one Amir here, but you can try different things or different conditions here depending upon your scenarios. So that helps to filter accordingly. So here we are going to use the distinct transformation, and that gives us the unique words only. So what we can do, we are going to create a new RDD here, and we are using the old RDD that we created on top of that here by flatten all the elements, and here what we are doing now, we're saying distinct. So give me the distinct records or values from this words RDD, and it's gonna be creating this distinct RDD, and then we collected that and printing that out. So I'm gonna go ahead and execute the code and show you. So you can see that we have and love, fast, big, and all that. So duplicate data is gone. We are seeing only the distinct values. So in this example, what we are doing a word count by using reduce by key. So in this case, what's going to happen, you have we can use the reduce by key, and maybe we want to add these different numbers. So if you remember, we have this use this pair key, and I created on top and right here, and we added 1 to each of the word. So that's what we have. So if I have Ali here, that's my key, Ali's key, Amir's key. So very first value here is key, and then the next one is the value. So in Ali we have a 1 here. So then we have again Ali here 1, and if I want to say reduce by key, that means Ali, and then is happening twice here, and then it has the value 1 and 1 here. So maybe I just want to add these 2 values but show only one time, so Ali and comma 2. So I will reduce by the keys. So here I'm applying lambda, and then I'm doing the same, exactly same thing that I explained you. I'm adding the value each time. So for each of the key, I'm just adding the value, and then finally I'm creating a new word count RDD. So it will be counting the word. So let's say Ali, and then it is 1 here, 1 here. So Ali comma will become 2, and then depending on the other records as well, if they can be reduced by the key, we are adding those values here. So if I run this one, what's going to happen? You are going to see I have this now. And is only happening 1. So and here you can see loves is twice, so that's reduced by the key. So loves is happening twice as we added the value, so number is there. So you have I was showing you Ali here somewhere, so there it is, right there. Okay, so that's also reduced. So this is how you will be using the reduce by key that tells the Spark if multiple entries have the same key word, add their values together. So that we have seen right here, that's what we did in our demo right here. So I thank you very much for watching this video. Please subscribe my channel, and I will put this code in description so you can use from there.